All right, this is video number 2 for the Pythagorean theorem. This is going to cover some other uses for the Pythagorean theorem. And the first thing we're going to talk about is a Pythagorean triple. So a Pythagorean triple is a set of 3 whole numbers that satisfies the Pythagorean theorem. So here's some examples. And these aren't things you necessarily need to memorize or anything like that. Some of them you will see pretty commonly, so you might get familiar with some of these. But for example, one of these numbers one of these Pythagorean triples is 3, 4, 5. So let's talk about why 3, 4, 5 is a Pythagorean triple. Well, let's try to plug them into the Pythagorean theorem and see if they work. 3 squared is 9, 4 squared is 16, 5 squared is 25, and we see that those two sides are equal. So those are 3 whole numbers that satisfy the Pythagorean theorem, and so we call them a Pythagorean triple. Now notice that it's not any set of 3 numbers that satisfies the Pythagorean theorem. They have to be whole numbers. So things like square roots that can't be simplified, decimals, fractions, things like that are not going to be showing up in our Pythagorean triples. Only positive integers or whole numbers. So if we take a look at some potential Pythagorean triples here, first off, let's look at 1, 2, 3 and see if this is a Pythagorean triple. So we're going to do 1 squared plus 2 squared and see if it's equal to 3 squared. Well, that gives us 1 plus 4 equals 9, which is not true. So 1, 2, and 3 do not form a Pythagorean triple. If we look at this next collection of numbers, 4, 4.2, and 5.8, we should know right off the bat that this cannot be a Pythagorean triple because we have some decimals in here. These are not all whole numbers, so they don't form a Pythagorean triple either. All right, let's try our last set of numbers, 12, 16, and 20. Let's plug those into the Pythagorean theorem. We square 12, 16, and 20, we get those numbers, 144, 256, and 400. And so we end up getting 400 equals 400, which is great. These numbers do satisfy the Pythagorean theorem, and so they are a Pythagorean triple. The other thing we're going to talk about is how to use the Pythagorean theorem to classify triangles. And here's what I mean by that. If we take A, B, and C being the sides of any triangle, so not necessarily a right triangle, we don't know what type of triangle we have here, but C is the longest side, A and B are shorter than C. And if we plug them into the Pythagorean theorem and we compare the sides, it tells us what type of triangle we have, whether it's acute, right, or obtuse. So if A squared plus B squared ends up being bigger than C squared, it's an acute triangle. If A squared plus B squared ends up being less than C squared, it's obtuse. And if the two sides end up being equal, then it's a right triangle, just like the Pythagorean theorem tells us has to be true for right triangles. So just like with the Pythagorean triple, let's look at a couple of examples and use these to classify the triangle. Now, before you do this, make sure the sides that you're dealing with can form a triangle at all. As you'll remember, at the beginning of class, we talked about how to do this. We need to make sure that the 2 smaller sides add up to more than the third side. So for example, 5 plus 6 needs to be bigger than 8. We get 11, which is bigger than 8. So good, we can go on to figure out what type of triangle this is. So we try to plug them into the Pythagorean theorem, see what happens. And it turns out that if we do this with 5, 6, and 8, the side with C squared ends up being bigger, which means it's an obtuse triangle. Or if that right side is bigger, it's obtuse. If the left side is bigger, it's acute. And if the two sides are equal, it's a right triangle. So in this case, it's obtuse. Now the second example, 2, 2, and 7, hopefully you can determine this, that that's not going to make a triangle at all. Because if we do 2 plus 2, that's only 4, which is not bigger than 7. So we don't have a triangle at all here. So we can't do this. It's just not a triangle. Now let's try for 9, 11, and 12. If we do 9 plus 11, we see that is definitely bigger than 12. 9 plus 11 is 20. So we're good to proceed. Let's plug them into the Pythagorean theorem and see which side is bigger. So in this case, we get 81 plus 121, and we want to compare it to 144. In this case, we get 202. So this time the left side is bigger, which means it's an acute triangle.